In this video, we're going to look at lateral surface area and total surface area. So let's say we have a building, and the building has a front that is 100 feet wide, and then it goes back 80 feet. And we'll say it just has a flat roof. Oh, and it's going to be, we'll say it's going to be 20 feet high. So if we wanted to paint this building, what we would be interested in doing is painting the front. And we'll just ignore the fact that there's a little door there. We'll pretend like we painted the whole thing. We want to paint the side. And then we know back here there's another side to the building. So we're going to paint that. And then we're going to paint the back of the building. So we're going to paint 4 surfaces. And each surface has an area. So let me redraw our building because it's getting a little messy so we can see what we're talking about here. So if we're going to paint the front is a rectangle that is 100 by 20. And we know the area of a rectangle is length times width. So 100 times 20 would be 2,000. And that would be square feet. So the area of the front of our building is 2,000 square feet. And then, so I'll say front for the area of the front. The area of the back of our building, it's going to have the same dimensions, 100 times 20. So the area of the back of our building is 2,000 square feet. And then if we wanted to talk about the left side of our building, it's still 20 feet high, but now it's 80 feet long. So the area of the left of our building would be 20 times 80, or 1,600 square feet. And then finally, the area of the right of our building, it has the same I wrote F instead of L. It has the same dimensions as the left side of our building, so that would be 1,600 square feet. Okay, so we're painting the buildings, and we're figuring out what is the square footage that we need to paint. And we figured out all 4 sides, we need to add them together. So 16 plus 16, that's 32. That's 52, 72. 7,200 square feet is what we need to paint. And what we just figured out is called the lateral surface area. So this is lateral surface area. And what you are doing is you're looking at a 3-dimensional object and you are figuring out what area do the sides take up, excluding the bases. So this would be a base and this would be a base. And we abbreviate this sometimes LSA. Now, there is another way to figure out the lateral surface area. You can also say the lateral surface area is the perimeter of your shape times your height. So let's do this calculation and see if we get to the same result of just adding the area of all 4 sides of our building. So the perimeter of our building would be the distance to go around it. So that would be 100 plus 80 plus 100 plus 80. So let's see. We have 100 twice, that's 200. We have 80 twice, that's 160. Add them together and we get 360 feet. and then we're going to multiply by the height. The height is 20. And when you do 360 times 20, you end up with 7,200 square feet. So we see that we actually do get to the same place with lateral surface area. Now the second type of surface area is called total surface area. So the total surface area takes into account the sides that we were just talking about, but it also takes into account the bases. So to figure out total surface area, or TSA, what you need to do is you need to figure out the area of your top, area of the bottom, and then the area of all your sides, and add them all together. Or you can use a formula. So the total surface area is the lateral surface area plus your two bases. And we just said that lateral surface area is perimeter times height. And you may remember from a previous video when we have capital B, what that means is the area of your base. So in this case, the area of our base is a rectangle. It would be length times width. Let's take our same store that we had before. It was 100 feet by 80 feet by 20 feet. We figured out previously that the lateral surface area was 7,200 feet squared, or square feet. Now we need to figure out the area of the base. The base is right here, and it's a rectangle, so we're going to do 100 times 80, or 8,000. And that would be square feet. Two times 8,000 would give us 16,000. And then we would add the two numbers together, and we would end up with a total surface area of 23,200 square feet. Let's try figuring out the lateral surface area and total surface area of a different shape. This time, let's take a look at a cylinder. And our cylinder is going to have a height of 10 meters and a diameter of 4 meters. Let's figure out lateral surface area first, because total surface area is simply lateral surface area plus 2 of the area of the base. Okay, so we're looking at the perimeter of this shape. Well, this shape is a circle, and we know that the perimeter of a circle is a circumference, and circumference is pi times diameter, or you could think of it as 2 pi times radius. We are told our diameter, and if you wanted to use this formula, you just divide your diameter in half to get radius. We're told our diameter is 4, so we're doing 4 times pi, and I kept 3 decimal places since this isn't my final answer, and I got 12.566 meters squared. So that is the circumference or perimeter of my shape. And then my height is 10 meters. So I'm going to multiply my perimeter by my height, and I end up with a lateral surface area of 125 point, we'll round to 1 decimal place, 7 meters cubed. Now we want to figure out the total surface area. Well, we've already done half the work because we figured out the lateral surface area. So this is the surface of this is the surface area of just this, not including the bases. That's lateral surface area. total surface area, we're going to include the bases. We know that the area of a circle is pi r squared. In our case here, our radius is 2 meters. So in parentheses, we're going to end up with pi times 2 squared meters, which would be 4 pi meters squared. And then we're going to multiply that by 2. And when we do that, we end up with 8 pi, which would be 100.53 meters squared. Add them together, and we end up with 226.2 meters squared. That's our total surface area. And I just realized that this should not have been meters squared. This was just a perimeter. That should have simply been meters. So meters times meters is meters squared over here, not meters cubed. That would be for volume. All right, so the lateral surface area is only taking into account this piece all the way around the shape. But now the total surface area is taking that into account, plus what is the area of the bottom and what is the area of the top.